Welcome everybody. Let's take a look at chapter 9, section 1, finding lengths and angles of right triangles. Our trig ratios, SOHCAHTOA. Oh, good song, I remember that. Deal with right triangles. We have to have an angle of interest, represented here by theta. Across from it would be our opposite side. Across from the right angle would be our hypotenuse. And next to the angle that we're interested in would be our adjacent. SOHCAHTOA tells us what ratio to use when we're trying to solve a trig problem. Sine OH. So opposite over hypotenuse. SOHCAHTOA. AH. Adjacent over hypotenuse. TOA. OA. O is for opposite. A is for adjacent. And we saw last class that we have 3 other trig ratios that we don't really use a whole lot in this class, but you might use them in future classes. So I just want you to be aware of what they are. The reciprocal of sine is cosecant. We take our ratio, we take the reciprocal, we flip it over. Cosecant is hypotenuse over opposite. It's not like you got to memorize something different. If you know SOHCAHTOA, you can always flip them over to get the reciprocal ratios. For cosecant, for secant, the reciprocal of cosine, we flip it over, hypotenuse over adjacent. And the reciprocal of tangent is cotangent. Take your opposite over adjacent, flip it over. The reciprocal is adjacent over opposite. What we're going to focus on though is SOHCAHTOA. And instead of cross multiplying like we did before, let's take a look at a more visual approach where we can write a pyramid and it's got 3 pieces of information. Maybe it's a pyramid with sine, opposite hypotenuse. Maybe it's cosine, adjacent hypotenuse. Maybe it's tangent, opposite over adjacent. And then, if we fill in what we know, we'll know 2 out of those 3 pieces. It will visually show us, do I multiply or do I divide to figure out the remaining piece? Let's try a few and see what I mean. Here is our little triangle. We've got a 35-degree angle here. We've got a right angle here. So we know we can use trig if we have a right angle. We have an angle and a side. This is telling me sine, cosine, tangent, right? SOHCAHTOA. If I have 2 sides and I want another side, that's Pythagorean theorem. But you have an angle and a side, you're using SOHCAHTOA. Well, here's my angle. This is opposite. C is across from our right angle. It's the hypotenuse. Which trig ratio works with opposite and hypotenuse? Opposite hypotenuse would be right here. So let's draw a pyramid, aka a triangle. Pyramid just sounds cooler. And we're going to fill in the pieces we know. We know that we have an angle, sine of 35 degrees. We know that the opposite is 11 over the hypotenuse, which is C. Well, this visually shows me how to solve it. If I say C is equal to, cover up the missing piece, cover up what I'm looking for, I get 11 over sine of 35. We put that in a calculator, we've got our answer. So let's put that in our calculator and see what we get. 11 divided by sine of 35. One thing to watch out for is your calculator does have to be in degrees. If you don't see DEG, you instead would see radians or gradients or something different. Then you would want to change it here with this DRG button. D for degrees. Radians is something we'll get to later on. But the problem showed me 11 divided by sine of 35. That's it. The hypotenuse is 19.18. Let's take a look at another one. Wow, the year I was born. How'd that work out? All right, so we've got a little right triangle with a 42-degree angle. What do we call the X? It's on the other side away from that 42-degree angle. This is my opposite. What's the side that's next to it? That's adjacent. So which of your three ratios, SOHCAHTOA, work with opposite and adjacent? Opposite hypotenuse, adjacent hypotenuse, opposite and adjacent. There it is. It's a tangent problem. In the bottom left corner, we put the tangent of our angle. So we have tangent of 42 degrees. Then we need opposite and adjacent. Opposite is X, adjacent is 7. To figure out what to do, we cover up the missing piece. Okay, I cover that up, and I've got two things that are next to each other. That's multiply. When you have one thing next to another, that's multiply. When they're on top, one on top of the other, that's divide. We're going to multiply. Tangent of 42 times 7, put it in my calculator, we'll have our answer. Tangent of 42, close your parentheses, times 7. So, my missing side, the opposite is about 6.3. If you prefer to have 7 times tangent of 42, you can reverse it. You can, order does not matter when you're multiplying. Any order is fine when you multiply. All right, give it your best shot. Try it out, hit pause, come back in a minute, see if you win it. All right, welcome back. Here's my 15-degree angle. This would be opposite. Hypotenuse is here. So if this is opposite, X must be the adjacent. Which ratio works with adjacent and hypotenuse? Adjacent hypotenuse, I hope you were using a cosine. Draw my triangle. Fill in what we know. Cosine of 15 degrees equals adjacent over hypotenuse. Cover up the missing piece. They're next to each other. We're going to multiply to solve. And like I said last time, it doesn't matter if the cosine comes first or the number comes first. You're multiplying. 2 times 3 is the same as 3 times 2. Order doesn't matter when you multiply. Put it in my calculator. Let's find out. 31 cosine of 15 degrees. I don't even have to put multiply. Having that number in front of cosine, it's automatically going to multiply. If it makes you feel better, put a times sign in between. You'll get the same thing. 29.94. There's my value for X. That was our missing side. Dear Math, solve your own problems. I am not a therapist. If at first you don't succeed, try doing what your math teacher told you to do the first time. Oh, I like that. All right, how about you guys take a few minutes and practice SOHCAHTOA? About 10, 15 minutes ought to do it. If you get stuck, I'll give you a few hints here before we move on. Hit pause. Time for a few hymns. All right, if you're stuck on number 2, here's your angle. This is opposite, this is adjacent. Figure out which ratio you're using. Number 3, angle of depression is 40 degrees. Well, this angle here is 40 degrees also. They are alternate interior angles, if you remember that from geometry. So if that's 40, that's 40. You're looking for the opposite and adjacent. Number 4, how tall is the Washington Monument? Oh my, this one looks challenging. This is a good one. So, you're standing here. You're looking up. Let's say you're about 5 feet tall. So that's what the 5 feet is for, from you till the ground. You look up at an 87.4 degree angle, you see the top of the Washington Monument, and you know you're standing 25 feet apart. You can calculate the height from the top to this 5-foot mark, like, to here. Take your answer, add your 5 feet, you'll have the height of the Washington Monument. Now the challenging one. How tall is the second part of the tower? It's not exactly half, it's just called a second half, that's all. Sometimes a half isn't really a half. English is weird. I didn't invent it. So you're looking for the x. You have 2 triangles. You have a little triangle that's 25 degrees. You have a big triangle that's 40 degrees. It might help if you draw 2 separate triangles. Put 25 in one, put 40 in the other, but both of them, this is 87. Why would you do it? The big one, you can find that distance. The little one, you can find that distance. What would you do with them to get what's left? Think of it this way. Let's pretend that this is 20 and this is 15. What's left? Yeah, 20 minus 15 would be 5. So take the full tower, subtract off this piece, you'll have the part for x. Okay. Good luck on your group work. Welcome back from group work. Let's take a look at the rest of your notes. I thought maybe we'd take a quick peek at the Greek alphabet. As you get into higher math, they use more and more letters. Some of these we've already seen. Some of them we probably know. For instance, hey, here's pi. We know that one. Right? Well, there's a capital pi and a lowercase pi. The Greek alphabet has uppercase and lowercase also. Are there any other Greek letters up here that you recognize, that we've used perhaps, or you've heard in a science class maybe? Well, we just talked about theta. We're using lowercase theta. It's the one that looks like a 0 with a belt on it. We've talked about delta representing change when we're talking about slope, change in the y's over the change in the x's. We're about to use lowercase alpha and beta. Looks like an A and kind of a fancy B. Sigma here is used for summation. That's a common one. Do I have to memorize all these? No! Unless you're going into a fraternity or sorority, there's a good chance you won't see a lot of these again. But I just thought it'd be kind of neat. Okay. Here we are, finding angles using trig. So we have an angle alpha in here. We know that this side is 9, this side is 5. And you might be thinking, oh, I have 2 sides, it's Pythagorean theorem. Yeah, that'd be great if you want to find the length of the hypotenuse, not if you're finding the angle. So, here's my angle alpha. This is opposite, this is adjacent. Which trig ratio? So, TOA works with opposite and adjacent. So tangent of angle alpha equals opposite over adjacent. If I want angle alpha, then what I need is inverse tangent. On your calculator, you press second tangent to get that, of 9 divided by 5. Let's put this in our calculator, find out how to do it. If we're looking for an angle, we use inverse tangent. If we already have the angle, we use regular tangent. So, second tangent. See a little inverse up there? Second sine, second cosine. So it depends on which ratio you're using. We want tangent this time, 9 divided by 5. I'm still in degrees. My angle is about 60.9 degrees. If you're looking for an angle, you go second sine, second cosine, second tangent. And the little symbol for degrees is that little circle. 60.9 degrees. Incidentally, if this is 60.9, start thinking about how would you find that missing angle up here if I were to ask you, because I'm about to. Find the measure of angles A and B. Oh wait, not A and B. Wow, it's Greek. Alpha and beta, right? Kind of looks like an A to me, or maybe even a fish. I don't know. There's our beta. Let's just pick one of them. How about we pick alpha? Alpha comes before beta alphabetically. So here's my angle. What do you call the 8? It's across from the right angle. If you said hypotenuse, you're right. What do you call the 3 that's next to angle alpha? Next to is adjacent. For this one, opposite would have been the one on top. If I'm doing beta instead, keep in mind, opposite and adjacent, they do change names. They trade places. Who works with adjacent and hypotenuse? SOHCAHTOA. Cosine. So, cosine of alpha equals adjacent over hypotenuse. Alpha would equal the inverse cosine of 3 over 8. Now we need a calculator. Second cosine of 3 over 8. Second cosine, 3 divided by 8. Alpha is about 68 degrees if you round. How can you find beta? Well, remember that a triangle, they all add up to 180, and 90 of it's sitting up here in that corner. So that leaves us 90 for alpha and beta. If we want beta, we just need to do 90 minus 68. You get 22 degrees. Could you have done a trig problem? Absolutely. But it'd be a lot more work than going 90 minus 68. All right, you guys are going to work on Desmos, sine, cosine, and tangent. Good luck, and make sure you are working with a partner. You'll also get, before you leave today, quiz practice for Chapter 9, Section 1. It's only on Pythagorean theorem and special right triangles. Your special right triangles, 45, 45, 90, 30, 60, 90. So Pythagorean theorem and special right triangles. There's no SOHCAHTOA on your quiz. Bye.